demonstration of kind of putting some things together that we've been working on. This is definitely Algebra 2 stuff. Okay, have that. I don't think you've been exposed to this. Okay, so we're simplifying complex rational expressions. Okay, so we have 1/2 plus 1/3 over 1/4. Okay, then I'm going to scoot this down. Okay, so adding or subtracting fractions, you have to have a common denominator, which involves all of that.
You want this right?
Yes. And then order of operations with fractions, we need to simplify the numerator or the denominator first before combining the numerator and the denominator. Okay, so following our steps that we have here, so we have adding or subtracting fractions, you have to have common denominators. So in this equation right here, we have an add and a subtract. We do not have common denominators, so we need to do that first. Okay, so what would, and not looking at this down here, because that's not part of it, it's going to be 6. Okay, so I would multiply this one by 3, and we learned that whatever we multiply the top by, we've got to, or the bottom by, we've got to multiply the top by. Okay, and then the same thing here. This would be 2, and this one. Okay, so now we have 3 over 6 that I'm adding to 2 over 6. Okay, so we have our common denominator. So when we add, I'm only adding the what? The numerator. Okay, so this becomes 5 over 6. Okay, so I have simplified. So our next thing was order of operations with fractions. You need to simplify the numerator or the denominator. It doesn't matter which one you start with. But you've got to make sure both of them are simplified before you combine the top with the bottom. Okay? Well, the bottom, there's nothing to do at the bottom. Okay? But what does this mean when we have a fraction bar and there's something on the bottom? Divide. Okay. So this is really 5/6 that's being divided by 1/4. Do we need common denominators? No. Okay, so right. So we're going to keep that. And then cross cancel to simplify. So I have 2 can go into there, 2 can go into there. So then my final answer would be 10 over 3. Okay. Just leave that. I haven't seen it where they've actually simplified that. we're going to have some that are going to have variables in them. So this is just starting as a basic one, which that would be 3 1/3, right? If we do reduce it, or knowing what's equivalent to it. Okay, so starting now, oh, no, that's more. This is actually what we'll be working on. I was just starting basic. Okay, so we're writing, so let's put that as number 1. These are actually what we do. But we're going to do the same concept of what we did with whole numbers. Okay, so we have b plus 3 over a. So that's the numerator. And then the denominator is b squared minus 4 over a squared. Good? Okay, so I'm just looking at the numerator right now. I'm going to simplify the numerator, then the denominator before I combine the two. Okay, so I'm just looking at this one right here. So common denominator, this is really over a 1, right? Like we do with whole numbers, we can put it, make it into a fraction. Okay, I need to get common denominator. What is my common denominator? A. So that means I need to multiply this by a and this by a. Okay, now just to keep it alphabetical when we do this, because we usually write x, y, a, well, same thing with a and b. Okay, so this is going to become ab over a plus 3 over a. Okay, so like we did in the last one, we don't combine these, we only combine these. Can I combine those when it's an add? No, that'd be like terms, right? So we're just going to leave it, okay, as AB plus 3 over A. We good so far? Okay, so now we're going to the bottom one to simplify that one before we combine it with it. Okay, so this is over 1. What is my common denominator? A squared. So I'm going to put a squared on this one. I'm going to go ahead and write it out. A squared on this one. Okay. So I'm not going to write it double like I did on this one because there's not anything we're combining. So we're going to write a squared, b squared, right? Because we can't put them together because they're two different variables. Minus 4 over my common denominator, which is a squared. Okay, so my numerator has been simplified and my denominator has been simplified. So this is what I have. We're just writing on this first one. You guys will find shortcuts and write things, okay? So I have AB plus 3 over A. That is being what? Divided by A squared, B squared minus 4 over A squared. Okay, just like we did with numbers, but now we've got variables, we're going to keep dot flip. Okay, so I'm keeping this one, so it was AB plus 3 over A, and then now I'm going to flip it. This one's on top now, so A squared over A squared, B squared minus 4. Just get my board up. Okay, now we're at where we just took a test on things. Okay, we're at a multiplication problem that if you can factor any of them down to cross cancel and simplify, then you need to do that. Okay, so my first fraction we can't. Second fraction you could. You could do the A thing if you wanted to. Otherwise, because I think we had x's in the last section, right? We had x squared and x for the cross cancel. So you can do that if you want to. This is a perfect square binomial. Okay, everything here is a perfect square. That's a perfect square, and the sign of the middle is negative. So that means I can do 2 parentheses to factor them down. One's a plus, one's a minus, and then I would have AB here, and then 2, 2. Okay, is there anything I can simplify?
Simplify, just take both the a squares out, both the a's out, and then squared converted to a b negative 3, so that was on the front.
No, yeah, what?
On that, could you just like toss up the
Yeah, and that's what we're talking about right now. And that is the only thing you can simplify in this. Okay? Because on top we have an AB plus 3, and on the bottom we don't have an AB plus 3, right? So that has to stay there. But then the A's, right, because this is multiplication. This is an addition problem, so it has to go with another addition problem. Okay? This one and this one are the only ones that we can simplify right now. Okay? So the A would go into the A squared and just make it A. Okay? So my final answer, because you can't cross cancel one of these with one of those. So it's just going to be AB plus 3 over AB plus 2. And that's as far as we can go. So we did simplify, just not much.
Oh, so you can't take the a from the top and get it across the a squared rule?
No.
Oh,
AB, yeah, because it's an AB. Okay, we're good? Okay, we're going to look at a what if, okay, for this next one. So I want you to write this. You can write what if you wanted to, or just write it down for this one, or just put a question mark. Okay, so simplified really is simplified unless you did A and A. Okay, simplifying this one we did on the other page, same thing. Okay, but this one's different than the last one we did. What? Right, so the AB plus 2 and the AB plus 2, and then this one with this one just like what we did in the last one. So then that means that this one is a lot more simplified, which should be A over AB minus 2. Okay, so just be cautious of that, paying attention to the positives and negatives. You cannot simplify this A with this A, okay? If that was not there, if the negative 2 was not there, then yes, you could, okay? Because then it's just a multiplication problem, okay? This is an addition problem, and it can only go away with another one that's exactly like that with an addition or subtraction problem, okay? All right, let's try this again. Little added extra step for this one. We have like multiple fractions. So 2 is by itself, plus, and then fraction is the second one. If you want to change the t's to x's, you can, because some people like confuses them with that. Okay, so you can write it as x over 2 plus 2 over 2 plus x, because the pluses and the t's are the same. This is just what was on the worksheet. Okay, and we'll put this as problem number 2. Okay, when I rewrite mine, I'm going to rewrite it as x. I hope that doesn't confuse you. Okay, so when we have ones like this that have like a fraction and a whole number, we want to take care of this part first. Okay, we want to simplify the numerator, simplify the denominator, combine the two before we factor in that other part of the equation. Okay, so I'm just going to rewrite this. So I have x over 2 plus 2 over 2 plus x. I would rewrite this just because we're used to cross-canceling things. I don't need to take out a -1 to rewrite it because they're both positive. Where's my raise? I'm going to flip this and make it x plus 2. Okay, my numerator is already simplified, right? So that one's fine. Okay, so I'll just remember that my numerator, this part, okay, is just x. Okay, but now I need to simplify these guys. Okay, so this is my denominator. This is over 1. Okay, I need a common denominator, which is x plus 2. Okay, so I'm just gonna go ahead and change this into an x plus 2, but what I do on the bottom, I've also got to do on the top. Okay, so when I distribute this, I'm going to have a 2x plus 4 plus the other numerator, which is 2, over my common denominator, which is x plus 2. Are we good to that? Okay. Technically, other than just adding the 4 and the 2, we're done. Okay. So this was my numerator. I'm going to go different color. This was my numerator, right? So it's x that is being, so there's t, or that's being divided by, right? So I'm going to do what with it when I go to write this one? Keep dot flip. Okay, so I'm just saying you need to write it out, like the division part, and then rewrite it as a flip and do that. Okay, so that means that this is going to be on top, which is an x plus 2. And then on bottom, I've got 2x plus 6. This is being divided by this, right?
Okay.
So the x is being divided by this, so we gotta flip it. I just didn't write the division part, because we don't do anything on it other than rewrite it to flip it. Okay. Now, is there any cross canceling that we can do on this one? Because even if I factored out a 2 on this one, okay, this would have x plus 3. Still not going to have anything that I can factor in, okay? So I think we're going to actually leave it broken apart because we might be able to factor it with a 2, okay? So now I've got this plus what this became, okay? So I'm just going to do this. Okay, so now I'm adding 2 because it was add 2 up here. Okay, when we have fractions, we have to have common denominators. Okay, so this is really 2 over 1, but it doesn't have the same denominator. So what do I have to multiply by? 2x plus 6. Okay, so then I would do the same thing on the top. So that makes go. Okay. So this one to this one, because we have our common denominators right now. So x times x is going to be x squared. That times that is 2x. Okay, so I'm done with that numerators. Now I'm simplifying this numerator. So that would be 4x. Distributing that one would be 12. Okay, that's just going to change to 6. Go good? Okay, and all of that's going to be over what? 2x. So the only catch on that one, which it's not, the only catch on this one would be that if we could factor this one down and cross cancel it with that, but signs are the same that add to give you 6. Factors of 12 are 1 and 12, 4 and 3 give me 7, right? And then 6 and 2 would give you 8. So if we factored it down, we couldn't factor it down to get 6. Okay, so this is your simplified answer. This one will be your hardest, longest steps. Okay, so the red part was first, and then the plus 2 is your second step. Okay, so the what if, so just put a question mark below it. Okay, if we got down to our final answer and we were checking this is what I was just talking about, that if we could factor this, signs are the same and they're both positive, and if we had x and x, what would my factors of 12 that added to give me 7 be? 4 and 3, okay? And then on the bottom, factoring this one would be a 2 and an x plus 3. So then you could go further, right? Because then you have the x plus 3 and the x plus 3. So then you would just have x plus 4 over 2. And you can't divide the 2 into the 4 because that's an addition problem on the bottom was it was subtraction problem. Yes, you have a question?
Where did you get the 797? Oh, is this just a one?
Yeah, so if we had 6x on the
Yeah.
previous one.
Okay, I was
So
thinking-
if it was, then you have to double check before you just write the answer to see if you can go further. Okay, so that's why I'm saying when we had to 6x, we think of our factors of 12, we have 1 and 12, 2 and 6, 4 and 3, none of those added to give you 6. Okay, but if it was 7, then that means, yes, it can factor, that top one can factor, the bottom one can factor down, and then you can simplify further. Okay, so this one and this one. Okay, last one I'm doing with you, and then you're going to try some. I won't give you a what if on this one.
What if not?
Do I need to go back?
I'll get back.
Okay. Okay. All right, so we have x plus 1 over x squared for our numerator, and then the denominator is x minus 1 over x to the third. So we're doing the same thing on this one, but we have a binomial that has a cube, so we're going to have a flashback. I think this was first semester on how to factor cubes. Okay, and there was an acronym that I think it's called an acronym. I'm not an English teacher. You know how we have, please excuse my dear Aunt Sally, to remember order of operations? There was a word that helped us remember how to simplify cubes. Do you remember what it is? Which hopefully all of you use on a daily basis, especially on your hands.
Soap.
There we go. Okay, so soap was same, opposite, always positive. So we're going to end up using that in this one, and that's why I wanted to do this one, because I'm sure you probably forgot how to do that. Because that was algebra 2 stuff, not algebra stuff that you have like practice more time. Okay, so now that I caused a bunch of anxiety, let's see. Okay, so simplifying the numerator. What is my common denominator? Okay, so I would multiply the bottom by x squared, right? And then the top by x squared. So that means on the top, this now becomes x cubed plus 1 over x squared.
X squared.
Good. Okay, now doing the same thing on the bottom. So x cubed times x cubed. Okay, so this is now going to become x to the 4th minus 1 over x to the. Okay, we're good to there. Did I not lose anybody? Everybody's still writing down. Okay, so numerator, denominator. I'm leaving the numerator, and then I'm going to dot into what with this one? Flip it. Okay, so the first one stays the same, so I'm just going to use different colors. So I have x to the 3rd plus 1 over x squared. It's being divided, but we're going to flip it and change it to multiplication. And so this one gets flipped. So x to the 3rd is on top over x to the 4th minus 1 on the bottom. We're good? Okay. So what we're remembering the SOAP acronym for is that first numerator. Okay? And so if you need to write this just because we have another one you don't remember. So SOAP was the same, opposite, always positive. And the two formulas were, so if you had the same, you would have an A plus B if it's a plus. Okay, so same, and then you would have A squared minus because it goes to opposite. And then AB, and then it's always positive. This was our formula. You try that.
I thought there was a button.
No, we're factoring it. We're not cubing another. We're breaking. We're factoring. But yes, there is a button for cubing. Okay, so if it's a negative, this one's a positive. Okay, so if you have a problem that winds up with a negative, it's going to stay the same. But then this one's going to be not a negative, it's going to be a positive because it's the opposite.
Are we gonna be using this formula?
Right now, I don't know. Yeah, we're using it right now to do the numerator. We got to factor this numerator. Okay, we good?
Wait, so the first thing.
This is the one we're factoring right now. We just have to remember how to, and you can only do that with cubes when they're binomial cubes. Last semester. Yeah. Okay, you got that written down, so that when you have that a cubed minus 1, you know that that's the order and the. We good? Okay, so in the first numerator, guys, in the first numerator, what is my a? Just x. Okay, so my a is x. What is my b?
The one.
The 1. Good? Okay, so this is a positive 1. Okay, so I'm going to be following and putting what I just said, my a and my b are in. Okay, so a is x, so I'm going to put x plus what? 1. Okay, and then what? I heard it. X squared minus 1x, right? You put those together as multiplication. So you can just put x if you wanted to. Plus 1. 1 times 1 is going to be 1. Okay, if you remember from that section, this second half looks like you could factor it, but most of the time you can't. I don't think we've ever come across one that can. Because factor is one that adds, if you do a negative one, that can happen. Okay, so we can't factor that down. Okay, so that top one's been simplified. X squared really is simplified. You could write it as x and x if you wanted to. Okay, x to the third. You can write it as x if you wanted to. Okay, this is a perfect square binomial. Okay, this is a perfect square, this is a perfect square, and the sign in the middle is a negative. So that means I can split it up into, and we're actually going to be able to go further. I'm going to split this up a little.
So then you just change that into x squared plus 1. Is it x squared plus yeah.
X squared minus 1, x squared
No, actually it would just be
1. Okay, but this is a perfect square binomial. So that actually means I can go further. Okay, so, okay, this right here, that's why I'm trying to get people to not talk while I'm explaining. So this is a perfect square, which means it can be split evenly. So if it was x to the third, we would have to go back to doing the SOAP thing, right? Or x to the fifth. You couldn't split it evenly. 4 you can split evenly, which is 2 and 2. Okay? Sign in the middle has to be a negative, because that's what gets rid of the middle term. And then 1 has to be a perfect square. Well, 1 times 1 is 1, right? That's your perfect square. So we do it as a positive and a negative, split it up, okay, and then 1 and 1. Okay, but this is still a perfect square binomial, so that means I can factor just that one further, not that one. Why is that one not a perfect square? Because it has a plus. Okay, so that's going to stay there. This can't be broken down further, but this is going to become x and so plus 1 and an x minus 2. And I'm just going to cross this out so we don't put that in part of our. Okay, so now we're looking for things that we can cross cancel. So do I have an x plus 1 on the top and the bottom? Yes. Okay, so I'm gonna do, so I've got an x plus 1 and an x plus 1. I don't have another equation that has the x squared minus x plus 1. Okay, what about these guys? Right. Okay, so this would go up to the top, right, and move smaller to larger, subtract the 2 from the 3, so it's just going to leave it as x. Okay, is there anything else that we can do? No. Okay, so my numerator is x times x squared minus x plus 1 over x squared plus 1, because we can't simplify that one further. And then the only other one that was left was the x. That is it. Welcome to algebra 2. Than that previous one? Even with the soap?
I don't know. I'm probably gonna get messed up. I already know.
Okay, here's your tray.